Right, Nana. So is it audible, right? Hello. Meghna వినిపిస్తుందా? Yeah. So last class what we were discussing now? So we are just calculating the pH calculations, right? For strong acid, mixture of strong acids, weak acid, the mixture of strong acid plus weak acid, right? We are doing all these calculations. Strong acid, mixture of strong acids, weak acid, mixture of strong acid plus weak acid. So mixture of weak acids. So today we will discuss this. So strong acids, I already told you 100% dissociation takes place. Here is Ka value is not needed, right? So up to, for example, 10 to the power of minus 1 to 10 to the power of minus 6 for aqueous HCl. Aqueous HCl, so we are neglecting the water, but only the thing is, important thing is 10 to the power of minus 7 and 10 to the power of minus 8 cases. So the H plus which is coming from acid as well as water we need to consider, right? So here the pH values now 6.79 I told you and 6.97. So pH calculations I told you how we need to do. If we are taking the 10 to the power of minus 9, so we'll take the only water because highly diluted case, that is highly diluted case I told you. And in case of H2SO4 or H3S, right, H3PO4 cases, the number of H plus ions it is giving, based on that we need to do the strong acid cases. And mixture of strong acids, so that I already told you, so M final is equals to M1V1 plus M2V2 by V1 plus V2. Otherwise, if they are giving the different acids, that cases, to avoid the confusion, so you can take the normality N1V1 plus N2V2 by V1 plus V2. So that I already told you in case of mixture of strong acids. And in mixture of strong acids, I told you one more important point, right? So not in this case, weak acids, in this case I told you, not in this case. So then third cases we discussed the weak acid. Weak acid cases, what we need to do? H plus ion concentration is equals to under root of Ka into C. So if you know the H plus ion concentration, so automatically what is alpha, Nana? Alpha value, degree of dissociation under root of Ka by C. So C, if it is concentration increases, alpha is decreasing, Nana. So inversely relationship. So based on that we discussed the weak acid. And the most important thing is the fourth one, when they are giving the strong acid and weak acid. So that cases we need to neglect the weak acid because of common ion effect. This is strong acid is dominates. So already this is weak acid, it is suppressing the dissociation of weak acid because of common ion effect. Common ion effect, I already discussed this mixture of strong acid and weak acid. If it is giving, simply consider the strong acid, neglect the weak acid, because that is percent of error is less than 1%, so we can easily neglect. To avoid the confusion, we can easily solve the question. And the last one, this is not that much of important, but so in this case, Nana, write the formula. Mixture of weak acids, H plus ion concentration is equals to under root P1 into Ka1 plus P2 into Ka2. Simply use this formula. So whatever the two acids, if they are given, so we need to follow this mixture of weak acids. So just write it down. C1 into Ka1 plus C2 Ka2. Hello. Hello.